Hello. Today is what's the day? July 9th, 2025. This is Workgroup Serving weekly meeting. Welcome everybody. Today we have light attendance, and the only topic is from Ashok. So take it away.
Yeah, let me share my screen. Sergey, if you can.
Okay. Let me make you a post. You should be able now.
Sounds good. Okay, today we'll do a project update on Inference Perf, since we recently had our 0.1 release. So we'll go over how the current architecture looks like, what are some of the key features. Jason has volunteered to do a demo, so I'll briefly show how the tool can be used today for different benchmarking scenarios. And we'll briefly discuss what is coming up next in the roadmap, and people have any questions can help answer too. So this is how our current architecture looks. We initially sort of started with the basic benchmarking library with our data generator, um, load gen, having a client to send requests to the inference endpoint. This can be um, any model servers, any production stacks like LLMD, Dynamo, etc. And we'll pull all the metrics that we can, and eventually we'll have a report that will be available. A couple of things we have recently done. One, we have like a good benchmarking API now, so you can use an YAML to specify a different data set use case, input-output distribution, traffic pattern. You can control the QPS and all that. And the benchmarking report actually comes with all the metrics, with like success failure rates and information that you can look at there. So the hope is that this API can provide like all the metrics that you need out of benchmarking, plus also provide a clean way that you can specify what conditions the benchmarking needs to be done under, right? So a couple of things that we are planning to extend. These are the dotted lines you're seeing here. These are mainly around like one, we want to have a deployment library which makes this easier to deploy the benchmarking tool. There is also discussions around plugging in different load generators, even from other benchmarking tools. Uh, if we want to reproduce like specific things that were run with other tools, so that's an option as well. So we want to kind of introduce that pluggable load generator option. Um, and we want to do more around like pulling metrics from the actual infrastructure underneath the accelerators and um, current utilization, power usage, and stuff like that. Yeah, so that's how it looks today. So with V0.1, these are the key features that we launched with, right? If I quickly open the link here, you should be able to see a detailed list of the features that we landed, and all the contributors that we had for V0.1. So we have like 10 plus contributors now from different companies, Red Hat, IBM, Capital One, um, and a few more. So yeah, if you're interested in contributing, um, yeah, please attend the benchmarking weekly meetings and we can follow up from there. So going back here, the main things we wanted to call out here, one is the tool is now pretty scalable. You can reach up to 10K QPS. This is one of the limitations that you often see with different benchmarking tools. With like they have a lot of times simple Python script which uses like async IO to drive load, but um, after like a few hundred QPS, it's not able to sustain because it runs into issues usually. So this is something we have worked on to address, to be able to hit a much higher QPS more consistently. So you can actually benchmark um, bigger systems with multiple replicas. Then we have different metrics, latency, throughput, model server metrics, and so on. You have the ability to use both real world data sets from Hugging Face and synthetic data set, which allows you to generate like different patterns based on your specific load and input output distribution, right? So today you can actually do pretty powerful things like generating a normal distribution by specifying your mean, standard deviation, and max input and output lengths. This allows you to control how exactly you want the data to be when you're using synthetic data sets, right? You can also send like fixed length if you want to. And there are multiple load patterns that you can simulate. If you want, you can have like a burst in traffic. You can continue to increase load to find what the saturation point is, and so on. Right now, we use the OpenAI compatible API. If you are using VLLM, it has been tested with that. LLMD has been running some benchmarks with it as well. And we have like more observability, like the metrics from model server, but also like we produce detailed request traces. So you can see how long a request took, at what time we received each of the tokens back, what was the failure, if any, and what the reason for that is, what were the input and output tokens at each request level. Everything gets logged. So it allows you to like replay things if you need to. It allows you to investigate more on what exactly was sent and what we observed, which is also something you'd find often lacking. And we also have some observability into the tool itself. A lot of times when you say this is a QPS you want to send, it's sort of like a best effort thing, and you have no observability into what exact QPS the load generator was able to send. So you have observability into that, where you can see, okay, this is my requested rate, and I was able to hit this QPS consistently. So to briefly touch upon the metrics, these are the main ones that we are presenting now as part of the report and collecting during the benchmarking run. This includes your time to first token, inter-token latency, normalized time per output token. Similarly, on the throughput side, you can separately see how many input tokens, output tokens, requests we were able to process every second. And on the model server metrics, we collect a few queue size, batch size, KV cache usage being some of them. But there are a lot more as well. Today we collect 10 plus metrics from the model server. So this kind of allows you to not only see what the benchmarking results were, but you can also see how the model server behaved during that benchmarking run, right? So you can correlate things like, okay, my KV cache usage was full, so that is why I'm seeing the numbers start to saturate, and so on. And all of them are presented in different percentiles, aggregated in different way, so you can find the exact thing that you're looking for. And in terms of the configuration, like I said, you have a YAML file that you can specify these different things, right? Today we support ShareGPT for chatbot or conversational data. You can have like synthetic one where we have a Sonnet data set that we split in different ways based on your input output specification. There is also a random generator one, which will generate random tokens from your model vocabulary and send that as the input. And there is a shared prefix data set, which allows you to benchmark prefix caching scenarios, right? Let's say if you want to, if you're enabling prefix caching, and like the inference gateway extension, it has a routing based on a prefix. It has routing that is like prefix aware, where it knows like which replica has the highest amount of prefix for your request and tries to route to that one. So those sort of cases you can test with this, right? Where we are able to tweak how much the prefix matching is, and how many different groups of prefix can be shared between the requests and so on. And then there are a lot of load generator options that are available too, right? You can control between Python versus constant time load. You can kind of describe the different stages in which load needs to be sent. What is the interval in between the different load durations and so on. Concurrency control is another thing that we have added where you can say, hey, I want to be able to have like these many processes sending requests, sending concurrent requests using these many workers over this period of time. So this is something the multiprocess architecture now allows us to get to a much higher QPS. So there is both automatic detection in setting it up based on the machine you are running your benchmark on, but also control to manually configure these things. And today can get started and either run the benchmarking tool locally. You can run it in Docker. We have container images that are getting published with each commit that is going into the tool. And then you can also run it on Kubernetes, where we have some manifest that tells you how you can deploy. I'll hand it off to Jason to do a demo of the tool.
Great, thanks. I'll need host. Okay, thank you. All right, you able to see my screen?
Yeah.
Great. So this is a look at the input config file that Ashok was referencing. I'm going to show an example of running a shared GPT run with 2 stages that run 1 request per second and 10 for 2 seconds each, just for the demo. I'll show that I have 2 pods running in my cluster. One is a Llama 3 8B VLLM deployment, and the other is my test container running the inference perf image. All you have to do once you have this configuration set up is start the tool referencing that configuration. So I'll go ahead and run it now. You can see the load configuration. It's running on a large VM, and so we're able to have 88 processes because there's 88 CPUs, and each process can do up to 20 max concurrency for now. So the load can actually go much, much higher than what's needed for Llama 3 8B. Each field of this configuration specifies the model you're targeting or the API, open AI API type that you're targeting. You can see here it's shared GPT, and we limit the requests or the input prompt size to 1024. And then the rest of these metrics and report allow you to configure what you want to see in the output. So if we take a look at this actually running, see that the load generator is running and completing each of the stages. You're able to see once this finishes that each report is generated, and it will show the achieved QPS versus the targeted QPS. And I have a previous run output that helps us kind of see what longer durations will actually achieve. And here's an example of one of those stage report files and the metrics that Ashok was referencing. In the load summary, you're able to see the requested rate for the stage versus the actual achieved rate. This one happened to run 1 request per second for 5 minutes. And you see that request latency and normalized time per output token and 0 failures. And you collect one of these report files for each stage. And then using the new analysis tool, you're able to target a directory that has those lifecycle metrics and print out graphs. So while it does that, you can see that the output failing to get Prometheus metrics for now because it's not set up, but you see these summary output files. So from that run that I just started, looking at the report file, you can see that it ran the lower load. And then we'll take a look at the charts from the previous run and see the charts that it generated, the latency versus throughput curve, where we hit saturation on Llama 3 8B and achieved a maximum of around 700 output tokens per second for 8B on the L4 setup. And there's a couple of other graphs that the analysis tool produces. This shows the exponentially growing output token time as your requests start queuing because your model server is saturated, and a breakdown of input, output, and total token per second. So you get a little bit better understanding of throughput for input versus output. I can hand it back to you, Ashok.
Thank you, Jason. Yeah, just to call out there, like Jason mentioned, with the concurrency parameters, we're able to drive much higher QPS. And as you can see with the config there are different things that we can configure that can allow us to get different load patterns that we want. Going back. So to quickly touch upon the roadmap, more accelerator metrics are going to be added soon. So this will give you like your GPU utilization and other things that you want to measure at the infrastructure level as the benchmark is being run. And broader support for more GenAI use cases, not just LLMs. We are looking at how to support diffusion and other model benchmarking here. And the deployment API, like I was talking about earlier, where we want to make it easier to deploy the benchmarking tool or different load generators. For example, if you're just using Python, how can we actually orchestrate the whole thing within that? So there is an open PR for that. We are trying to figure out how we can merge that and how that works in conjunction with the actual benchmarking library itself. And then advanced traffic patterns around how we can split traffic to different models and use cases. This is something the inference gateway a team has been interested in, so we want to make sure that case is well supported. And lastly, like more data sets, having the ability to replay traffic. Like I mentioned earlier, we have these request traces, which allows you to eventually replay these through the benchmarking tool. But how can we actually replay traffic from, like, for example, VLLM logs and other places if it is in a certain format? So that is of interest as well. And if you're interested in contributing, participating, and learning more about the benchmarking tool and the work around this, please attend one of our weekly meetings. And we have a Slack channel on Kubernetes Slack. You can post any questions and stuff that you have related to this there. And there's a link to the GitHub repository, so you can take a look at the code and start playing around with it. Yeah, that's all I had. If you have any questions that we can help answer. I saw Sachin join as well. Sachin is one of the maintainers on the tool too, so he can help answer questions as well.
So Rita asked in chat, do you want me to read it or you can read it yourself?
Yeah, I can take a look. So the question there is, is this being used by LLMD to show the ideal case for using disaggregated serving? So it can be used for that. Right now, we have run some tests with LLMD using disaggregated serving to sort of see how time to first token, inter-token latency, and throughput varies. So we can definitely use to compare that with like setup without disaggregated serving. Yeah. So today there it has been used to get some initial numbers, and we are trying to integrate into the CI/CD process there. But we can do similar comparisons if needed. So,
I wanted to know, like, what would you like? How would you use the accelerator metrics, and would that be helpful in terms of identifying, like, if you're using the hardware efficiently or not? Like, is that what you're gonna do? What's the plan there?
yeah, that it's mainly that, right? When we are running our model servers, we want to make sure our utilization is good. If we are able to get higher utilization by tweaking certain things, we should be able to get that by looking at accelerator metrics plus specific model server metric like KV cache usage, right? That's mainly the reason to add those. I know the IBM research team are also working on making inference more power efficient. So they're also interested in getting like power usage stats from the accelerators. So how can we operate at a similar power but get more by doing by how we set up the inference stack itself, right? So all those things you can get by pulling model server metric while the model server is running at a specific load, right?
One more question. Is like, I saw that the script also generates some images, and then that shows you like what the performance was like. I was wondering, like, if the inference tool itself generates some sort of Prometheus metrics, then that can be looked into Grafana. You know how Grafana
Yeah.
allows you to look at a particular time window, and then you all the different graphs and charts that you have also then modified to that particular window. So that's, I guess, beneficial, something that could be a feature of the project.
Agree. Yeah. Today, actually, if you have Prometheus installed, will basically pull those and show us like aggregate metrics. We didn't go through that as part of the demo, but you can see like an aggregate of Prometheus metrics as part of the report. But yeah, technically, like if you have Prometheus, you'd most likely have a Grafana or some dashboard on your side that you can look through and correlate during the benchmarking run how it looked. And maybe we can even pull like screenshots or things from your dashboard, right? That might be useful as well. Yeah, we can look into those.
One more question. Sorry.
No, go ahead.
Like, I was wondering, like, if you know how most of these hosted model serving API that you have, which are OpenAI compatible, they also have like a pricing with like per million token. I was wondering if there was a feature in the project that allowed you to also calculate like cost per million token, like if if
Yeah,
if user would to put hourly charge or something for that particular VM or GPU machine they're using, and then we can like extrapolate that to figure out what the per million token cost could be.
yeah, I agree. We can, that should be pretty easy to do, I think. So that's a good feature request if we can create an issue on the repo, we should be able to get that added because we have all the throughput data that we need, right? If you put like hourly instance charge for the setup you are using, I should be able to get cost per million input and output tokens.
Cool.
Cool. Any other questions?
Is there any feedback you want from model servers? So like what kind of feedback are you looking for? And like if you're talking about this project with some other people, like how would you position it? Is it to adjust your gateway settings or to give like configure your LLM better?
Yeah, I think the benchmarking is sort of integral to getting ideal performance with your model servers, right? And it also helps you, like the point Rita was making around analyzing like different configurations, like if I set up disaggregated serving, how that performs versus not, and all that. So the main thing is to run this tool to find how you can get the best out of your inference stack, right? And use the output to further optimize your setup. If I were to position this, I would basically say, since we are able to send pretty high load and have good coverage with all these observability, any production serving stack that you're looking to set up, you can use this, right? You're able to run with like multiple replicas, big deployments and all that. So all those cases, this should be a good tool that you can use. Yeah. And for feedback, I would say, yeah, if anyone runs this, I would like to know, yeah, how you are using this today, and specific feedback like adding reporting cost is something we can add. So more such requests if you have, let us know and we can get it added. Suraj?
I was wondering if apart from like a regular simulating regular chat conversation as a part of benchmarking, is there a way to also do RAG applications or agentic applications?
Yeah, so this is something that has been discussed before. We haven't looked into specifically adding scenarios focused on that. But I think we should be able to do it, because at the end of the day, you're still hitting your specific inference endpoints, right? And if you want to simulate like a RAG use case, you want to make sure the data set and the actual, if it needs to be preflow heavy and all that, we should be able to test those too with the appropriate data set, or like have a synthetic one which kind of resembles it, right? So yeah, that too, if you have some use case there that you're looking at, we'd like to learn more about and see how we can support it through this.
All right, thank you.
Cool. Yeah, I saw Rita respond in the chat as well. Yeah, it is exactly for cases like that where it's hard to tell which setup is better and how we can get the best out of the GPUs. So that's where this can be most useful. Cool. We have no more questions. We can end that. And yeah, please take a look and let us know if you have more feedback, feature requests. We are looking at V011 release soon with some recent bug fixes and the analysis tool and all that. So we'll continue to add more. Thank you.
Thank you, Ashok and Jason. A great presentation. With that, if there is no more agenda item, let's make it an end. Thank you, everybody, very much.
Thanks.